Hello everyone, this is Maverick Paul, the chemistry guru. Now in this video, we want to discuss the suggested solution for 2021 A-Levels H2 Chemistry Paper 1 question 25. Now question 25, the ore iron 2 chromite FeCrO4 is mined in the Philippines and Afghanistan. The first stage in the production of chromium from chromite is the reaction with oxygen in molten sodium hydroxide to form sodium chromate. Formula is given Na2CrO4. We should ignore oxidation of iron in this reaction. So we just need to focus on chromite to chromate. So how many moles of oxygen molecules are required to react completely with 1 mole of chromite ions? And we have 4 options and we want to determine this answer. Now, if you consider reaction with oxygen, most likely this is a redox reaction. So the topic tested in this question will be under redox reaction. And what we have to figure out in this case is, the question mentioned it is the reaction with oxygen in molten sodium hydroxide. And the question also mentioned that we are converting in the first stage in the production chromite Cr2O4 2-. I've removed the iron 2+ because iron 2+ doesn't take part in the redox reaction here. Cr2O4 2-, and it is being converted to CrO4 2-, sodium chromate. Again, we ignore the Na+. So we just focus on CrO4 2-. Now, the first thing we have to determine is, during this reaction, who is oxidized and who is reduced. If I consider oxidation state for chromium in chromite, oxidation state for chromium is +3. Then oxidation state for chromium in chromate, CrO4 2-, oxidation state for chromium is actually +6. So therefore, we know that your chromium actually undergoes oxidation, increase in oxidation state from +3 to +6. So I know that this is an oxidation, which would mean that oxygen will undergo reduction, since the redox reaction is always one species oxidized and one species reduced. It also makes sense because a reaction with oxygen usually means that the species undergoes oxidation, and I know that oxygen undergoes reduction. Now what is interesting is, what would oxygen be reduced to? And if you notice, inside this information, the question did tell us that you are reacting oxygen in molten sodium hydroxide, and we have our OH- here. So we know that the solution or the reaction is under alkaline medium, and this would mean that most likely oxygen would be reduced to OH-. So let me put this here. The product with respect to oxygen should be to OH-, and this will be a reduction from oxygen to hydroxide. Change in oxidation state for oxygen here from 0 to a -2. So this is the first thing we have to determine. What is the expected product that we will have, and who is oxidized and who is reduced. And essentially there are 2 methods that we can use to determine what is the number of moles of oxygen reacting with our chromite. First method that we can use is we try to balance the overall redox reaction, and from there we can determine the mole ratio. So let us take a look at the first method here. Involving balanced half equation method, what we will have to do is we will have to split to oxidation half equation and reduction half equation. By right, we will have to balance this in alkaline medium, since the question mentioned that this is in the presence of sodium hydroxide. And what we can do is we can just balance this half equation in acidic medium for oxidation half equation, balance the reduction half equation in acidic medium, then we add the 2 half equations together, then we convert this to alkaline medium. But it actually isn't really necessary for us to convert this to alkaline medium, since converting from acidic medium to alkaline medium actually doesn't really affect the mole ratio, and therefore it doesn't really affect the answer. So for the sake of MCQ, since this is an MCQ question, what we will do is we will just focus on the balancing of the half equation in acidic medium, add the 2 half equations together, then we'll have an overall redox reaction in acidic medium, but we're not going to convert it to alkaline medium, since it's actually not really necessary. It doesn't affect the mole ratio, so that we can do this a lot faster. Actually, there's no need for us to balance the whole equation. Later when we run this through, we will talk about it. Alright, so let us settle the first oxidation half equation involving Cr2O4 2- to CrO4 2-. First species that we will balance will be the element. So I have to balance chromium. There are 2 chromium on the left hand side. I need 2 chromium on the right hand side. So I will need 2 CrO4 2- to balance chromium. Then typically what we will do for balancing half equation, we will balance oxygen using water. So on the left hand side, there's 4 oxygen. On the right hand side, I have 8 oxygen. I need 4 oxygen on the left hand side. I'll have to balance this using 4 water. Then the next thing is I'll have to balance hydrogen using H+, 8 hydrogen on the left hand side. I need 8 H pluses on the right hand side to balance hydrogen using H+. Finally, balance charge using electron. Left hand side, 2 negative charges. On the right hand side, I'll have 2 times -2 is a -4. -4 plus 8, I'll have a +4 charge. So in order for me to balance the charges, -2 on the left hand side plus 4 on the right hand side, I'll have to add electrons on the right hand side. How many electrons? I'll need to put 6 electrons on the right hand side, so that left hand side overall charge is a -2, right hand side overall charge will also be a -2. So this is the oxidation half equation involving chromium. Now the next thing we do is we have to settle the reduction half equation involving O2 to OH minus. Now O2 to OH minus, same idea here, balance oxygen, the species that undergoes redox reaction. So O2, 2 oxygen on the left hand side, there's only 1 oxygen on the right hand side. So therefore I need 2 OH minuses on the left hand side to balance oxygen. So next thing we do is we balance hydrogen using H+. So I have 2 hydrogen on the right hand side, and therefore I need 2 H pluses on the left hand side. Then finally balance charge using electron. I have 2 minus charges on the right hand side. Left hand side it is a +2 charge. So I should be adding electrons on the left hand side. Number of electrons we should be adding is 4 electrons. So that on the left hand side will be a -2 charge. On the right hand side is also a -2 charge. Again, you notice what we are doing here is we're just using the 4 steps to balance the half equation, balance the element, balance oxygen using water, balance hydrogen using H+, balance charge using electron. Even though this should be done in alkaline medium, but what we can do by right is I can add the 2 half equations, which is balance in acidic medium. Then I'll get the overall balance equation in acidic medium. Then we can convert it to alkaline medium when we have the overall balance equation. Again, it doesn't really affect this outcome, and it doesn't affect the mole ratio. So once I have the oxidation half equation and the reduction half equation, I can add the 2 half equations together to get the overall balance equation. Of course, what we would be looking out for is the electrons, because when you add the 2 half equations together, the electrons have to cancel. So we will have to modify the half equation and make sure that the number of electrons for both half equations is the same. Basically, we're trying to find the lowest common multiple for 6 electrons versus 4 electrons. Now 6 and 4, the lowest common multiple should be 12. So in order for me to modify this oxidation half equation, I will need to double, all right? And the reduction half equation, I will need to times 3, so that I'll have 12 electrons here. Maybe I can put this on top. I'll have 12 electrons here. Then the coefficient for electrons, in this case, since it is 4 times 3, will also be 12 electrons. Then when I add the 2 half equations together, the electrons will cancel. Then the electrons will disappear to get the overall redox reaction. Now, when we add the 2 half equations, even though there are many terms here, but we actually only need to focus on the reactant, our chromite, and oxygen, because we just need the mole ratio involving these 2 guys, correct? So what we can do is we can just focus on your chromite and O2. I know that the oxidation half equation I'll have to double, so this guy actually will be 2, coefficient 2. And if I consider oxygen when it is undergoing reduction, this reduction half equation I will need to times 3, so this coefficient for O2 will be 3. And again, there are many other terms here including the products, but we're actually not really bothered about it. I just need the mole ratio involving my chromite and O2. So when I add the 2 half equations together, what I would end up with will be something like this. I'll have 2 CrO42 minus plus 3O2 and the rest of the terms. Now, are we interested in trying to figure out the rest of the terms? Of course, if this were a structured question, then we will need to settle the rest of the terms. For us to have a proper and full equation, then we will have to convert this to alkaline medium. But for the sake of MCQ, we only need the mole ratio involving chromite and O2. So once we have this, then you notice the mole ratio involving your CrO42 minus and O2, we will be able to figure out, because the question did ask us involving the number of moles of oxygen molecules required to react completely with 1 mole of chromite ion. So now this redox reaction is in terms of 2 moles of chromite ion. So all I need to do is I just need to divide this equation by 2. If I divide this by 2, then this will be a Cr2O4 2 minus, then this will be a 3/2 O2 plus whatever. Again, what the rest of the terms are, we're not so bothered about it. Now I know that 1 mole of chromite ion will react with 3/2 moles of O2. So the answer is out. We already know this will be 3/2 moles or 1.5. So the answer to this question will be B. 1.5 moles of oxygen molecule is required to react completely with 1 mole of chromite ions. As mentioned previously, there's another method for us to determine the mole ratio between your chromite ion and O2. The other method is by comparing oxidation state. So maybe let us just briefly run through this idea. Let's talk about it. Now, if I consider the reactants and the product, I know that the reactant is CrO4 2 minus and the product is CrO4 minus. This is an oxidation state for chromium increased from +3 to +6. And we also understand that your O2 will be reduced to OH minus. There's a decrease in oxidation state for oxygen from 0 to a -2 oxidation state. Now, if I consider the oxidation and we focus on the change in oxidation state for the species, I know that there's an increase in the oxidation state for chromium from +3 to +6. So your chromium oxidation state increased by 3 units. So each chromium actually loses 3 electrons for me to increase oxidation state by 3 units. So one CrO4 2 minus species consists of 2 chromium. So each chromium loses 3 electrons, then each chromite Cr2O4 2 minus ion will lose a total of 6 electrons. Each one of them lose 3, so 2 of them combined will lose 6 electrons. This is involving oxidation. Now, how about reduction? Reduction-wise, oxidation state for oxygen decreased from 0 to -2. So oxygen oxidation state decreases by 2 units. Each oxygen actually gains 2 electrons. Involving O2 molecule, oxygen molecule, there are 2 oxygen atoms obviously. So each oxygen molecule will gain a total of 4 electrons. So first thing we figure out is, okay, each chromite ion loses 6 electrons. Each O2 molecule gains 4 electrons. Then the next thing we do is, since this is the same redox reaction, we will have to try to combine them together. And let's take a look at it. If I consider 1 mole of chromite ion, since the question is focusing on 1 mole of chromite ion, the number of moles of electron lost by 1 mole of chromite ion will be 6 electrons. We have already mentioned this here, correct? Each Cr2O4 2 minus loses 6 electrons. The number of mole of electron lost by 1 mole of Cr2O4 2 minus will be equals to 6. And since this is the same redox reaction, this electron loss must be equal to the number of moles of electron gained by X moles of O2. We want to solve for X basically. And I know that this is a redox reaction. Redox reaction is a total transfer of electron. Electron loss by Cr2O4 2 minus has to be the electrons gained by O2. So the number of mole of electron lost by 1 mole of Cr2O4 2 minus, which is equal to 6, it will be equal to the number of moles of electron gained by X moles of O2. Now I can do comparison involving X moles of O2 since it gains 6 electrons. Then how many electrons will be gained by 1 mole of O2? 1 mole of O2 will gain 6 divided by X moles of electron. And now we can tie this idea to what we have deduced previously. We know that each oxygen molecule will gain 4 electrons. And I know that 1 mole of O2 gains 6 over X moles of electron. So this will mean that 6 over X will be equals to 4. And now I have an equation, very simple equation involving X. 6 over X is equals to 4. I just need to rearrange it. I solve for X. X will be equals to 1.5. Of course, we end up with the same answer. The number of moles of oxygen molecule required to react completely with 1 mole of chromite ions will be B, 1.5. Of course, if you compare both methods, some of us will find it a little bit more tedious for us to use the first method, trying to balance the half equation and then add the 2 half equations together to figure out the mole ratio. Some of us will find that method a little bit tedious, but it is a little bit more straightforward because we don't need to do that much reasoning. Whereas for method number 2, what we can do is we can actually try to think about it, and we can work out the change in the oxidation state, and we figure out the value for X, or the number of mole of O2 reacting with 1 mole of chromite, by thinking about it, by reasoning out. So ultimately it depends on the preference involving the student. So see which method that you find more intuitive, and we want to make use of either of these methods, depending on the preference, to determine, of course, the same outcome. Alright, so that was the discussion involving this redox question. So if you have learned something useful from this video, please give me the thumbs up, like this video, and subscribe to my YouTube channel for more weekly video lessons. That's all for now. I'll see you next week.